Have you ever wondered how data is exchanged between devices on separate networks? It's a fascinating process akin to the postal system that ensures letters and packages are delivered to the right addresses. This delivery system of the digital world is governed by the Internet Protocol, or IP. It's the set of rules that make sure your data gets where it needs to go. The latest version of IP is IPv6, which was designed to overcome the limitations of its predecessor, IPv4. Consider IPv4 as a small town with a limited number of houses. Delivering mail to everyone can be a challenge. IPv6, in contrast, is a sprawling metropolis with virtually unlimited addresses. This makes data delivery much more efficient. IPv6 addresses are considerably longer than IPv4 addresses, allowing for a vast number of unique addresses. While IPv4 addresses are 32 bits long, IPv6 addresses expand this to 128 bits. This is like moving from a tiny village to a city teeming with homes and businesses. The format of IPv6 addresses also differs from IPv4. Instead of periods, they use colons to separate blocks of hexadecimal digits. Picture IPv4 addresses as North American home addresses with 5 or 6 digits, and IPv6 addresses as European home addresses with 10 digits. This results in an enormous increase in the number of unique addresses with IPv6. IPv6 provides different types of addresses, each with a specific purpose. Global unicast addresses, for instance, are like street addresses that everyone can use to send mail. Unique local addresses are like private mailboxes, only accessible by people within your neighborhood. Link local addresses are used within a single network segment, like addresses for your mailbox and your neighbors. Multicast addresses are used to send data to a group of devices, similar to sending a letter to a mailing list. Lastly, anycast addresses are like GPS coordinates, directing data to the closest device with that address. The sooner a company implements IPv6, the better. This helps future-proof the network and avoids the costs and disruptions of a last-minute transition. IPv6 also boasts several security improvements over IPv4, shielding devices and data from cyber attacks. However, don't forget that implementing IPv6 requires upgrading hardware and software, planning and preparing for the transition, testing the network, and training employees. There are risks involved, such as limited compatibility and security concerns. Therefore, it's wise to implement IPv6 gradually, thoroughly test the network for compatibility, and set up robust security measures like firewalls and intrusion detection systems. In conclusion, by embracing IPv6, a more secure, scalable, and future-proof network awaits. It's a step into a vast city of possibilities, ensuring efficient and secure data delivery for the digital age.